Hi everyone, this is Remy, and this video is going to cover the Math 124 note outline for section 1.5, which is linear equations, functions, zeros, and applications. So first of all, an equation is a statement that two expressions are equal. So something equals something else. A solution to an equation is the values of the variable or variables which make the equation true. So that means if you plug in a certain number for a variable and it makes the equation true, then that's a solution to an equation. And then a solution set is the set of all solutions of an equation, because there might be more than one solution. And then a linear equation in one variable is an equation that can be expressed in the form mx plus b equals 0, where m and b are real numbers and the number m is not equal to 0. So these two examples are both linear equations because it is possible to rearrange them until they get into this form. And we're just going to solve these two. So for part A, we have a lot of fractions going on. We could just start right off the bat by subtracting 3 from both sides, but what I'm going to do is eliminate the fractions instead first and then go from there. So to eliminate the fractions, we have to find the least common denominator between the denominators. So here we have the denominators 6 and 4, so we want to think of the least common multiple that they both share. Well, 6 and 4 can both go into the number 12 evenly. So that's the number we're going to use, and we're going to take that and multiply both sides of the equation by that number. So I'm going to take the left side of the equation, multiply by 12, equals, take the right side of the equation, multiply that by 12. And then in our next step, we can distribute the 12 across these parentheses. If we multiply 12 times 5/6, we can say that 12 divided by 6 is 2, times the 5 is 10, so we have 10x, plus 12 times 3 is 36, equals, and then over here I'm going to do something kind of similar to multiply these two, because I have 12 on top and 4 in the bottom, so 12 divided by 4 is 3, and then times the -7 we get -21. And now, by multiplying by that LCD on both sides, we've gotten rid of all the fractions, so that's nice. And now we can just solve it like we normally would. We're trying to get x by itself, so subtract 36 from both sides. So 10x equals -21 minus 36 will be -57, and then x equals -57 over 10. And it is fully reduced, so we're done. So solve means get the variable by itself. And if you plug this back in for the original x value, you're going to get a statement that's true. If you multiply 5/6 times -57 over 10, and then add 3, you'll get -7 over 4. And you should check that. I'm not going to go through that, but it's always a good idea to check your answers. Okay, and then let's go on to part B. Solve this. Here I'm just going to ask myself, well, what am I allowed to do? Well, one thing I can do is distribute the 7, and also I'll distribute the negative sign across these parentheses. So 7 times 2y is 14y. Minus 7 times 3 is 21, equals. If I distribute the negative to each of these terms, this positive y becomes negative y, and then the negative 3 becomes a positive 3. And now solving, again, means get the variable by itself. Well, I have the variable on the left side, and I also have it on the right side. So I need to get those all over to the same side, so I'll add the y over to this side. So I get 15y minus 21 equals, if I add the y to this side, they cancel and I'm left with 3. And then let's add 21 to both sides. If I add 21 here, we're left with 15y equals, add 21 to the right side, 3 plus 21 is 24. And then lastly, this is 15 times y, so to undo the 15, we'll divide both sides by that. So if we divide by 15 on the left, they cancel, left with y equals 24 divided by 15. And this time we can reduce this because the top and the bottom are both divisible by 3. So y equals 8 over 5 if we divide the top and bottom both by 3. So always reduce your answers if possible. Alright, so this was just practice in solving linear equations. And now certain things can happen when you're going about this process that are kind of different than usual. So these are going to be special cases when solving equations. So case 1, say you're going along and solving an equation, and then you reach a point where you get a true statement. In that case, the solution set is all real numbers, meaning any number you plug in for the variable will make the original equation true. And since any number can make it true, there are infinitely many solutions. And then second case is if you are solving an equation and you reach a point where you get a false statement. In that case, the solution set is empty. So that means that no matter what number you plug in to the original equation for the variables, you can never make that equation true. And thus there are no solutions. So let's see what that looks like down here. So for example, solve this equation. Alright, well, let's just go ahead and start distributing the negative 3. So we get negative 3b minus 6 equals 5 minus 3b. And then it's kind of like this example here where we had y's on both sides. So we wanted to get all the y's to one side, so we did that by adding this y to both sides. Same thing here, we want the b's to all be on one side, so I'm going to add this 3b over. But if I add 3b here, the minus 3b plus 3b's cancel. So if I add 3b to both sides, both of them go away, and I'm just left with negative 6 equals 5. Alright, and now we have this equation. It doesn't have variables anymore. So what is this equation saying? Negative 6 equals 5. Well, that's absolutely false. Negative 6 does not equal 5, so this is false. Therefore, we say no solution. Or we'd say the empty set, which just looks like two curly brackets with nothing inside them. So what this is saying is you could plug in any number you want for b, and you will never be able to find one that makes the left-hand side equal the right-hand side. Let's do part B now. we have negative 4x plus 1 equals 1 minus 4x. Well, if we add 4x to both sides, it'll cancel with this one, and it'll cancel with this one, and we'd be left with 1 equals 1. Well, what do you think about that statement? Well, 1 equals 1, that's true. This is true. So in this case, we'll say that the value x can be any real number. And then there's multiple ways to say this. You could also say that it's anywhere from negative infinity up to infinity. Or you could say the answer is all values x such that x can be, let's say x is a real number. So any one of these options is fine. Same thing down here. You can say anything like this, depending on which case you're in. Okay. So those are our two special cases. If you get a statement that's absolutely false, then no solution. If you get a statement that's absolutely true, then there's an infinite amount of solutions. X can be any real number. And then the variable you use here, though, is whatever variables in the original equation. So if this said m here and m, then you'd say m can be any real number. Alright, let's move on to the top of page 2. Now we're going to talk about zeros of linear functions. A zero is an input c of a function f. If the output for the function is 0 when the input is c. Okay, so what that's saying is, so you have a function and you plug c into the function and then it spits out 0. If that happens, then you know that that number that you plugged in, c, is called a 0. So first let's just practice deciding whether a number is a 0 of a function or not. So how about x equals negative 3? Is this a 0 of this function? Well, to find that out, you plug negative 3 into the function, so we'll replace this x with negative 3, equals 3, and we'll replace this x with negative 3 plus 5. Alright, so 3 times negative 3 is negative 9, and then we'd add 5, so we'd get negative 4. Well, when we plugged this number in, we got the number negative 4. We didn't get 0. So f of negative 3 turned out not to equal 0, so that means the number x equals negative 3 is not a 0 of the function f. Alright, let's do another one. Part B. Is x equals negative 5/3 a 0 of this function? Well, we're going to check that by doing the same thing. We're going to plug negative 5/3 into the function. So we're going to find f of negative 5/3 equals 3 times negative 5/3 plus 5. So just replacing all the x's with negative 5/3. And then solving this side, the 3's cancel, and we'd be left with negative 5 plus 5, which is 0. So f of negative 5/3 turned out to equal 0, so x equals negative 5/3 is a 0 of the function. Alright, so these ones were just giving us a specific number and asking us, is that number a zero of the function? But what if we just had the function itself and we wanted to find the zeros? Okay, so that's what we're going to do in this next example. It says now find the zeros of this. So we want to know what number could we plug in for h to make this part equal 0? Well, to do that, let's just write down that we want that to equal 0, and then we can solve for h, and that will give us what makes it 0. So we'll add 12 to both sides, so 6h equals 12. Divide both sides by 6, we get h equals 2. So this should be our 0. So this is our 0 of the function g. And you could check if you want. If this is a 0, then when we plug it in to the function, find g of 2, it should give us 0. So if I'm plugging in 2 here and here, that looks like this. Then we get 12 minus 12 is 0. So it is a 0. So that's zeros. And now I think the rest of the section we are just going to do real world applications now. So switching a little bit, but all these examples are going to involve linear functions. Alright, so the top of a rectangular pool has a perimeter of 520 feet. Okay, perimeter, of course we have to know what that means in order to think about what this question is saying. So perimeter means the distance around something. And it's talking about a rectangular pool. So it's a good idea to always draw pictures, if you can, representing the scenario. So this says that the perimeter is 520 feet. So that's saying all the way around. If you traveled around the pool from one point all the way back around, it would be 520 feet. Okay, and then it says the length is triple the width. If that's true, what are the surface dimensions? Okay, so the dimensions it's asking for are length and width. That's what we're trying to find. Well, if we call this side the length and we call this side the width, I'm going to put a W here for width, and then it says the length is triple the width. So if I wanted to write that out mathematically, I say the length, L, equals triple the width, so 3W. The length is triple the width. So instead of putting L here, I'm going to write 3W. And the other piece of information that I have is the perimeter is 520 feet. So let's write that the perimeter is 520 feet, but we also know that the perimeter is this distance around here, so it's 3W plus this W plus 3W plus this W. So since these two things are equal to each other, they're both equal to the perimeter, I'm going to write that 520 equals that, 3W plus W plus 3W plus W. So the perimeter is 520 feet long, and then let's just solve this. Well, 3W plus W plus 3W plus W is 8W. So we have 520 equals 8W. And then to get W by itself, we can divide both sides by 8. 520 divided by 8 is 65. So we've got the width. Now we need to find the length. But we wrote up here that the length is 3 times W. So we're just going to replace W with 65 because we know that that's what it is. So 3 times 65. So the length is 3 times 65, which is 195 feet. This one's 65 feet. And then we have reached our answer. Okay, let's go on to the top of page 3 now and do another one. Water accounts for 55% of a woman's weight. If Kathy weighs 110 pounds, how much of her body weight is water? So this one we just kind of have to convert the first sentence into an equation. So first of all it says water, so let's just call that W. And it says it accounts for 55% of a woman's weight. So the water is equal to 55% of the weight. If you ever have a percent, you need to convert it to a decimal when you put it in an equation. So 55% is going to be 0.55. And then the word of something is multiplication. And then here, the woman's weight, let's just call that X. So we came up with an equation just by going along word by word in the sentence. Water is 0.55 times the weight. So let's write that down, that W equals 0.55x, and then W means the water, and X means the woman's weight. And then if Kathy weighs 110 pounds, how much of her body weight is water? So we're looking for what W is, and we know the weight, so we know what X is. So all we're going to do is plug the 110 in right there. So W equals 0.55 times 110. And if you do that multiplication, let's just do it. 0.55, 0.055, 0.506, and the decimal will go there. So about 60.5 pounds is water. And that's that one. So this example and then the one we just did on the last page about the pool, those you just kind of have to come up with an equation that you know is true based off of the information that they give you. And so each one is going to be different, so it just takes practice with a variety of different problems to get the hang of creating the equations for those problems. And then the rest of this page is going to be dealing with a specific topic, which is simple interest. And so these next two examples, you're going to use the formula that we're going to talk about here. So it's the simple interest formula. So the simple interest I on a principal amount of P dollars at interest rate R for T years is given by I equals PRT. So what that's saying is if this is the amount of money you start off with, maybe for a loan, and then the interest rate of the loan is R, and then you take the loan out for T years, this formula, if you plug in those numbers for P and R and T, will give you how much simple interest you're going to have to pay on the loan. So this first example, after 36 months, the interest on a 4% simple interest loan was $600. So how much was the original amount of the loan? So we have to identify which values out of I and P and R and T, which ones we know already and which ones we're being asked for. So for 36 months, obviously that's time. But notice, for this formula to work, time has to be in years, and it's not in years right now. This says 36 months. Well, 36 months means time is, that's 3 years. So T is going to be 3. And then it says the interest on the loan was $600. So interest is this $600 over here. So the interest on the loan was $600. So this amount is our I value. That's the interest. And then this percentage is obviously the rate. But just like I said up here, that if you ever have a percent, you have to convert it to a decimal. So I'm going to do the same thing here. So 4% as a decimal is 0.04. And then lastly, let's read the actual question. It says, how much was the original amount of the loan? Okay, well that's the principal amount P. So it's asking for P. We do not know what P is. And we're talking about simple interest, so let's write down the simple interest formula and plug in what we know and leave what we don't know. So we said that that was the $600. So replace that with 600. P, we don't know, so I'm going to leave that as P. R, we know is 0.05, or we know is 0.04. And then T is 3, because remember we have to convert it to years for this formula to work. And now we just isolate P. So first, let's multiply 0.04 times 3. Well, that's like, this is like having 4 pennies, and if you have 3 groups of that, now you have 12 pennies, so 0.12, and then divide both sides by 0.12. And then, I don't really like dealing with decimals inside my fractions, so I'm going to get rid of the decimal by multiplying the top and the bottom by 100. Because if I multiply this bottom number by 100, then this decimal will move twice to the right. So I get 12, and whatever I do to the bottom, I have to do to the top. So I'll move this decimal point to the right twice, and I get 60000. And then that makes the division much easier. 60,000 divided by 12, well, 60 divided by 12 is 5, and then I have 3 more zeros. So the original amount of the loan was $5,000. Let's do another one about interest. Nick took out a simple interest loan for $1,500, and he wants to pay the interest off after a year. And if the rate of the loan is 7.5%, how much will he pay? Well, this time it's going to be different than up here because it's asking for a different variable this time. Because it says that he wants to pay the interest off, so how much is he going to pay? Well, that means it's asking for what the interest is. So this time we don't know interest. And then in the last example, we were finding how much the original loan was for, but this time we already know the original amount of the loan. So this is our principal value. That's how much the loan was to start off with. And then he wants to pay it off after a year. Okay, well, that's time. And this time it's already in years, so we don't have to convert it like the last example. So time is 1, and then the rate of the loan is 7.5%. And once again, I'm going to convert that to decimal form. So move the decimal to the left twice, and I get 0.075. And now let's just write down the formula and plug everything in. So this time we don't know I, so I'm going to leave it as I. This time P is 1500 times R is 0.075 times T is 1. Alright, so all we have to do is multiply these two numbers together. So I am just going to go ahead and multiply those two numbers off to the side. So 0.057000501. So just be really careful when you are doing this multiplication by hand. Okay, but if you multiply these two, you get 112.5 for your interest. And that makes sense. His loan was $1,500 and he paid $112 in interest. This one makes sense as well. The original amount of the loan was $5,000 and he paid $600 on interest for that one. So for these, anytime it's dealing with interest, you're going to be using this formula, I equals PRT, and then just be careful identifying your different variables. Let's move on to page 4. Alright, now we are going to talk about a different formula, the motion formula. So the motion formula deals with distance and speed and time. It's like traveling in a car somewhere. So this formula is the distance d traveled by an object moving at rate r, meaning the speed, in time t, is given by d equals rt. So the distance that something goes is equal to its speed times the amount of time that it's been going. Two notes before we get into the examples. Sometimes you'll hear words like tailwind, headwind, downstream, upstream. So we're just going to do a quick review about what those words all mean. So if you have a tailwind, then that's going to increase your speed. That helps move you along. So tailwind helps, therefore you're going to add to your speed. And then headwind's the opposite. If you have a headwind, that means you're like driving or flying into the wind, so that's going to hurt your speed. So headwind hurts your speed, so in that case you're going to subtract from your rate. And then say you're traveling in water. So if you're in a river and you're going downstream, that means you're going along with the direction of the current. So downstream, you're going to be going, it's going to help your speed because it's going to help make you faster. So this one you're going to add to your speed. And then upstream is the opposite. Upstream means you're going against the current. So that's going to hurt your speed. So in that case, you'll have to subtract from your rate. Okay. So first example, an aircraft that can travel 580 miles per hour in still air, that means no wind, is flying with a 20 mile per hour tailwind. How long will it take the plane to travel 900 miles with the wind? Let's write down, we know this is distance and speed, so let's just write down the formula, d equals rt. What's the distance? Well, it wants to travel 900 miles, so that's our distance. Now what's our rate? Well, the speed it normally goes is 580 miles per hour. However, it's traveling with a 20 mile per hour tailwind. So let's look up here. Tailwind is going to help our speed. So we're actually going to say that the rate is 580 plus 20. So for this rate here, I'm going to replace it with 580 plus 20. And then the question asks, how long is it going to take this to happen? So we don't know what t is. So let's leave t as t. And now we just get t by itself. So parentheses first, 580 plus 20 is 600. And then divide both sides by 600. Alright, so we got t by itself, and then we just got to reduce this fraction. Well, obviously this is going to reduce to 9 over 6. And that reduces to 3 over 2. And 3 over 2 means 1.5. So the time is going to take 1.5 hours to do this. And always think about, does your answer make sense? Well, if an aircraft is traveling at 580 miles an hour, and then they got that 20 mile per hour tailwind helping them, then it makes sense that it would take about an hour and a half to travel 900 miles. And then let's do this last one. A train leaves a station and it's heading north at a speed of 60 miles an hour. An hour later, another train, so we got two trains going here, another train leaves the same station and travels north on a parallel track at 80 miles an hour. How long is it going to take that second train to pass the first train? So the second train's leaving an hour later, however, it's going faster. It's going at 80 miles an hour compared to the first one of 60. So at some point it's going to catch up to the first train and pass it, and that we want to know when is that going to happen. So let's just write down the different information for each train. So here's the first train, and here's the second train. And we know we're dealing with distance and speed, so let's just write that equation down for both. So for the first train, I'm going to call it d1 equals rate 1 times time 1. And the second train I'll do slightly different, d2 equals r sub 2 times t sub 2, just so that they're a little bit different so we can tell them apart. Alright. So the distance of the first train is equal to, well, the rate is 60 miles an hour, so I'm going to replace the rate with 60. And we don't know how long this is going to take, so let's just leave the time as time. We also don't really know the distance yet either, so the only thing we know about that first train is that it's going 60 miles an hour. And then similarly for the second train, we know that the rate is 80 miles an hour for that one. But something extra that we know about this second train, we also know, since this train is leaving an hour later than this train, that means this first train is traveling for more time. So we know that the train 1's time is an hour more than train 2's time. Okay. We know that the time that the first train is traveling is 1 hour added on to the time that the second train is traveling. So what I'm going to do is replace T1 with that. So now I have, let's write it down here, I guess, that the distance of train 1 is equal to 60 times train 2 plus 1. So now we are going to take this information and this information and use it to help us answer the question. All right. So we want to know how long is it going to take for the second train to pass the first train. So that's going to happen when they've traveled the same distance. So we want to know, when does the distance of the first train equal the distance of the second train? Well, let's replace D1 with this. So D1 is 60 times T2 plus 1 equals, and then we'll replace D2 with this expression, 80 T2. And now look at what we have. This is actually a linear equation, and we have T2's on both sides, so eventually we want to just isolate the T2. So let's distribute the 60. So we get 60 T2 plus 60 equals 80 T2. And now I want to move the T2's to one side. So I'm going to actually subtract 60 from both sides, that way I don't get a negative number. So this 60 stays here. Subtract 60 T2 from both sides. 80 T2 minus 60 T2 is 20 T2. And then divide both sides by 20. So we get 3 equals T2. So that's the time. So it will take 3 hours for that second train to catch up to the first train. So that concludes the section 1.5 note outline.